This section is on dividing by a binomial using the synthetic division method. There is one other method, which is called long division, that will work anytime you're dividing by a binomial. The synthetic division is just kind of a shorter method that you can use to get to the same answer as what you would be doing with long division. For synthetic division, you want to make sure that the polynomial that you're dividing, your numerator, is in the correct order, descending order, highest exponent first. I'm going to look at the coefficients of those terms. So the coefficient of x squared is 1, the coefficient of x is 2, and then I have my constant 10. You take those three numbers and write those out without the variables attached. And this is kind of our setup for synthetic division. The number that will go on the outside will be the constant part of your binomial that you're dividing by. Okay, now synthetic division works best when you are just dividing by a binomial of the form, we say x minus c. That means your leading coefficient is a 1. So here my leading term is a 1. The only number I'm concerned with is the constant, is that c. So we always take that number, put it on the outside, and change its sign. So if it's a positive, when I have it in my problem, it will be a negative. Okay, it'll change to a -5. So step 1 will be to bring down the first term. So this 1 is going to be brought down. And then we're going to start multiplying. 1 times -5 is -5. 2 and -5, you're going to combine. That will be -3. Once you bring a number down under the bar, you're always going to be multiplying it by your outer number here. So -3 times -5 would be a positive 15. Combined, since they're both positive, we're going to add. So that would be 25. The numbers across the bottom, the 1, the -3, and the 25, will represent the answers to this division problem, but I have to go back and plug in the variables. So I look at the polynomial that I'm dividing. The degree is 2 because it has an x squared. I will always start 1 degree less than that polynomial, so here it would be x. So my answer would be 1x minus 3. The last number is always going to be your remainder. Sometimes you will not have a remainder, just depends on the problem. So to write my answer, I would have x minus 3 plus 25 over the polynomial that I divided by, which was x plus 5. So you always put your remainder over the binomial that you're dividing by. Always use a plus sign here between those. So how would I check division? Okay, you would take the polynomial that you divided by, which was x plus 5, and multiply it by the quotient that we get here, x minus 3. So this part I'm just checking. You don't have to do this. X times x would be x squared. X times -3 is -3x. 5 times x is 5x. 5 times -3 is -15. So I would have x squared plus 2x minus 15. And then I have to take my remainder, which was 25, and add that back in. And so I get x squared plus 2x plus 10, which was the original polynomial that we divided here in the problem. Okay, that's just a way to check that you can check it by multiplication. On your homework, if it asks you for the quotient and it has a blank for that, and then separate a blank for your remainder. Okay, sometimes the problems are set up like this. You would just type x minus 3 as your quotient and 25 as the remainder. But now if it does not have that blank for the remainder, you will type your answer the way that I have it here in the box. Okay, let's look at another example. X squared plus 12x plus 35, all divided by x plus 5. So again, the top polynomial is in the correct order. So I'm going to list those numbers only. So 1, 12, and 35. On the outside, the opposite sign of this constant that I'm dividing by, so a negative 5. And then we draw a horizontal bar, skipping a space below. The first number, which is the 1, will always come down, and then we start multiplying. So 1 times negative 5 is negative 5. Positive 12 and negative 5 would be a positive 7. 7 times negative 5 would be negative 35. Positive 35 and negative 35 would combine to be 0. So remember that last number is always your remainder. This means that we don't have a remainder divided evenly. Go back, substitute your variables in. So if I'm beginning with x squared, that means my answer will begin with just x. So my answer would be x plus 7, since that's a positive 7.